Hello everyone, welcome to my YouTube channel. Myself Hardik Shetty, currently pursuing in second year engineering in Sri Venkateswara College of Engineering, Vidyanagar, Bengaluru. Today we are going to discuss about One-Way ANOVA. Introduction to ANOVA. Before discussing about One-Way ANOVA, we should know what is ANOVA is. ANOVA stands for Analysis of Variance. ANOVA is statistical test that examines the differences in means across groups when the independent variable has more than two levels. It's a powerful tool for understanding the relationship between a categorical independent variable and a continuous dependent variable. Then, what is the use of ANOVA? It provides an alternative to multiple t-tests, reducing type 1 error risk. Then, when to use one-way ANOVA? It is mainly used in comparing means across different groups or treatments. Examples are testing the effort of different fertilizers on plant growth, comparing test scores from students across different teaching methods. Next, assumptions of one-way ANOVA. The first one is normality. The data within each group should follow a normal distribution, that are histograms, QQ plots, Shapiro-Wilk test. Next, homogeneity of variance. The variances of the group should be approximately equal, that are Leven's test and Bartlett's test. Next, independence. Observations within and between groups should be independent. Next, terminology in one-way ANOVA. The factor includes the independent variable. Example are teaching method. The levels are categories within the factor. Example different teaching methods. Next, responsible variable are the outcome measured. Example test scores. Next, the hypothesis in one-way ANOVA. Null hypothesis. There is no significant difference in means between the groups. Alternative hypothesis. There is a significant difference in means between at least two groups. In examples are in alternative hypothesis, not all means are equal, but in null hypothesis, all means are equal. Next, calculating one-way ANOVA. Between the group variability measures the variance between the group means. Within the group variability measures the variance within each group. In F statistic, ratio of between group variability within group variability. Next, step 1. Calculate total sum of squares. Step 2. Calculate between group of sum of squares. Step 3. Calculate within group sum of squares. Step 4. Compute F ratio. F ratio is measured by dividing mean square between and mean square within. Next, interpreting the F statistics. F statistic is defined as indicates if there is a statistically significant difference between group means. Critical value and p-value. Compare F statistic to critical value from F distribution tables. If p is less than alpha, for example 0.05, the null hypothesis is rejected. That implies significant group difference. Next, visual representation. ANOVA table example shows sources between or within, sum of squares, degrees of freedom, mean squares, and F values. Next, graphical representation. Use box plots to visualize spread and differences across groups. Next, practical application of one-way ANOVA. Business. Comparing sales across regions. Education. Accessing different teaching methods. Healthcare. Evaluating treatments or intervention methods. Next, limitations of one-way ANOVA. Assumption sensitivity. Requires normality and equal variances. Limited to one factor. Test one factor only. For multiple factor, we need to use two-way ANOVA. Next, does not identify specific differences. ANOVA only indicates that there is a difference, not which groups differ. Next, summary and key takeaways. One-way ANOVA helps test if there are significant differences between group means, reduces type 1 errors compared to multiple t-tests, ensure assumptions are met, and use post-HOC test for specific group differences. Thank you, and that's all for this video. For more videos, subscribe to my channel and please like this video. Thank you.